Transmission of heat. Transmission of heat. Nature and properties of radiation. Nature and properties of radiation. Radiation is nothing but electromagnetic waves. So heat energy will also travel in the form of electromagnetic waves. Every body except those at absolute zero, every body at temperatures higher than absolute zero emit these radiations. Every body except those at absolute zero emit these radiations. Two bodies at different temperatures exchange heat energy even if there is no material medium between them. Heat transfer is quickest in this process. Due to radiation, heat transfer takes place quickly than conduction and convection. The range of wavelength is about 800 nanometers to 4 lakh nanometers. The range of wavelength is 800 nanometers to 4 lakh nanometers. These waves are generated due to the vibration of charged particles. These waves are generated by the vibration of charged particles. Since heat radiation is also electromagnetic waves, so their properties are nothing but those of electromagnetic waves. They travel in straight lines, they travel in vacuum with the speed 3 into 10 to the power of 8 meters per second, 3 into 10 to the power of 8 meters per second. They follow the laws of reflection, refraction and total internal reflection. They undergo reflection, refraction and total internal reflection. They obey inverse square law. They exhibit the phenomenon of interference, diffraction and polarization. They increase the temperature of the bodies on which they fall. They are detected using thermopile and bolometer. Pivot's theory of heat exchange. Every body radiates heat energy irrespective of its temperature, but should be above absolute zero. Bodies at absolute zero do not radiate heat energy. It also receives energy from its surroundings. The rate of emission is independent of the presence of other bodies. If a hot body is placed in a room, heat is exchanged between the walls and the body. The rate of emission by hot body is more than the rate of receiving the radiation. The hot body emits more radiation than it receives. The rate of emission by hot body is more than the rate of receiving the radiation. The exchange continues till the temperatures become equal. At equilibrium state also, the rate of emission is equal to the rate of receiving radiation. The body emits radiation and receives radiation, but their rates are equal. Conduction and convection also takes place before the equilibrium is attained. After attaining equilibrium, there will be only radiation. There will be exchange of radiation by. After attaining equilibrium, there will only be exchange by radiation, but not by conduction and convection. Emissive power of a body. The amount of heat radiated per second. From unit surface area over unit wavelength range is called emissive power. It is denoted by E lambda. It is denoted by E lambda. If dq is the heat energy emitted, over the wavelength range, lambda to lambda plus d lambda, in the range lambda to lambda plus d lambda, then emissive power is given by E lambda is equal to dq by d lambda. E lambda is the property of the body. SI unit of emissive power is joules per meter square per second. SI unit of emissive power is joules per meter square per second or watts per meter square. Its dimensional formula is mt to the power of minus 3. The amount of heat radiated by a body depends on the surface area, the temperature of the surroundings, the time for which the radiation is emitted. The amount of heat radiated by a body depends on the surface area, its temperature, the temperature of the surroundings, and the time for which the radiation is emitted. Absorptive power is the ratio of the amount of heat absorbed to the amount of heat incident over the wavelength range lambda to d lambda. Absorptive power of a body, it is the ratio of amount of heat absorbed to the amount of heat incident over the wavelength range lambda to lambda plus d lambda and over unit surface area of the body. If dq is the amount of heat incident per second per unit wavelength range, at a particular temperature, and dq lambda is the amount of heat absorbed, then absorptive power A lambda is equal to dq lambda by dq. A lambda is equal to dq lambda by dq. Black body radiation. A body that absorbs all the radiation incident on it is called a black body. There is no reflection and transmission. When heated, the body radiates over all wavelength ranges. The radiation consists of several wavelengths. The emissive power is maximum, its absorptive power is 1. The emissive power of this black body is maximum and its absorptive power is 1. The radiation depends on the temperature. The radiation emitted by a black body depends on temperature. The emission is independent of the nature and shape of the body. The emission is independent of the nature and shape of the body.